In this video, we'll be solving a Math Olympiad question. The question is to prove 11 to the power of 10 minus 1 is divisible by 100. We're going to solve this question in two ways. So let's see the first way. So first, we're going to use the geometric series. So then the geometric series, the formula is 1 plus r squared, then up to r to the power n, then equals 1 minus r to the power of n plus 1, then divided by 1 minus r. Okay, so then we're going to apply this formula to our question. So because here we have 11 to the power of 10, so we're going to do this. So we're going to do 1 plus 11 squared, then up to 11 to the power of 9. Then here r is 11, then n is 9. So then apply the formula here. We have 1 minus 11, 9 plus 1, here's a 10, in the bottom 1 minus 11. So the bottom, that's negative 10, so then both top and bottom times negative 1, so we have 11 to the power of 10 minus 1. So then from here we have 11 to the power of 10 minus 1, then here both sides times 10, so here times 10, then here the sum, then 1 plus 11 squared, then 11 to the power of 9. Because question is a proof, 11 to the power 10 minus 1 is divisible by 100. Because here we have 10 already, so then we just need to prove this part is divisible by 10. So now let's do the sum of last digits of each numbers. Okay, so now let's see here. The last digit of the first number is 1. The last digit of this one is 1. Same thing here is 1. So then we notice the last digit of each number just 1. Then how many numbers we have here? 10. So that's why here we have 10 ones. So the sum just 10. So what that means? So that means for this sum, the last digit is 0. So that means this sum is divisible by 10. So that's why, so we have then the 11 to the power of 10 minus 1 is divisible by 100. Because we have 10 here, we have 10 here. So then we just prove this question. Okay, so now let's see the second method. So the second method, we're going to use a binomial formula. Okay, so then the formula is here. Just a plus b to the power n. Then here just sum I from 0 to n. Then here just n, choose I. Then a to the power n minus I. Then b to the power I. Okay, so we're going to apply this formula to our question. So this is our question. So then 11 to the power of 10 minus 1. Then 11 equals 10 plus 1. Then to the power 10 minus 1. Then for this part, we're going to apply this formula. So then here we have, then here the sum, I from 0 to 10. Then 10 choose I. So then 10 to the power 10 minus I, then b is 1. So then 1 to the power I. So let's expand the sum. So then here we have, so first 10 choose 0. So then here's a 10 to the power 10. So next one, 10 choose 1. Then here's a 10 to the power of 9. Then keep going. So then here we have, then 10 choose 8. So then here 10 squared. Then here next one, so here just 10 choose 9. So then this one 10 to the power 1. then 10, choose 10, then 10 to the power 0. So then here we should have outside minus 1, because here minus 1. So then here outside minus 1. Okay, so let's simplify each term. So then this one just 10, this one's 1, so here's a 10 to the power 10. And this one just 10. Then to the times 10 to the power 9. So this term, the coefficient, that's 45. Then 10 squared. Then this term, so this one is 10. Then here's a 10. Okay, so then last one here, so that's 1. Then outside minus 1. Okay, so then let's see. So these two canceled. So then here we have 10 times 10, so that's 10 squared, 100. So here we have 10 squared. So then each term has a factor of 10 squared. So that's why 11 to the power of 10 minus 1 is divisible by 100. So that's why, so we have a conclusion. 11 to the power of 10 minus 1 is divisible by 100. So then we just proved the question. Thanks for watching. See you next time.